Yeah, thanks for inviting me to speak today. What we're going to talk about is modelling threats out in the open source. So I quite like the pun. Anyway, a little bit about me. I'm a developer advocate for SOOCon23, who deal with dependency management tools, about software supply chain tools to help us all out. They also do a lot of open source stuff as well, which is very good. Take a look, a particular lift. I've worked as a developer for 10 years. I've done various languages, and I've been interested in cybersecurity for just as long. About 3 months into my first job, many years ago. Basically, I got hacked, and it's quite embarrassing to say, but it was a very important lesson to learn how to, because instant response on the fly when you don't know what you're doing is an eye-opener, that's for sure. I'm now qualified in cybersecurity. I'm not an Australian rugby player. That's somebody who's a few years younger than me, and I think he should change his name, even though he's more famous. So what is threat modelling, and why should we care? You know, this is the kind of thing, right? We have a lot of people that say about threat modelling being good, but it's actually quite difficult to sometimes explain that to people as why it's really important. It's a great quote, Victoria Drake from OWASP, the Open Web Application Security Project. You know, this is how they start their explanation. Threat modelling works to identify, communicate, and understand threats, mitigations within the context of protecting something of value. And I think that's an important thing at the end, the something of value. It doesn't mean that it has to be open source. It doesn't mean that it has to actually be cyber, in fact, or IT. You can model anything you want. Obviously for today, open source is the best, is ideal, but it doesn't have to be that. A few years ago, we had Adam Shostak, Zoe Braterman, and Elisa Miller, and quite a few others. They created what's called the Threat Modelling Manifesto in 2020. Threat modelling can take quite some time sometimes. One thing that's, as a developer, I experienced, and also experienced the other end trying to get people to do it, is that after you do a few sessions, some people go, we don't want to do this anymore, you know? Or, you know, they feel that there's a barrier between security and development. This manifesto kind of was looking towards, a bit like what the Agile Manifesto did for Agile. This is looking to what threat modelling, the same thing. So it's four main questions, and that's really all threat modelling is. What are we currently working on? What can go wrong? What are we going to do about it? And did we do a good job after we've implemented it? And if you think about that, threat modelling is quite simple. It's not, I don't think any question there is anything that a developer would be that shocked about either. You know, that's what they probably review at the end of every sprint, right? If you think of those questions of like plan, do, act, and check, it's kind of the same thing, right? And, you know, there's a real kind of importance of why we should care because, you know, criminal was going to crime. You know, I really didn't like that. What I wanted to do was do criminal was going to crim, but my English sensibility didn't really like that one either. But what is important is, you know, the various attacks that kind of happen day in, day out these days. So without scaring too much, you know, VMware rescue ransomware over the weekend, in fact, you know, outdated versions. They're now part of a ransomware attack. You know, 30 to 40% of all Log4j downloads are still of the vulnerable version 1 year on. You know, these things, you know, are used by criminals day in, day out to basically attack us. And if we actually had some kind of threat modelling in there, as well as tools, you know, you could use dependency tools, but in particular threat modelling at the beginning, we could ask those questions. What tools are you using? Is your software up to date? Do you have a plan for this? And again, it's asking questions. How can we improve on that? So I'm going to talk about some threat model frameworks around that. You know, this is not an exhausted list. There are very many. But these are kind of the more popular ones. Now, I'm not going to say which one is the best, because what you'll find is that actually, dependent on what you're modeling, they all have their benefits, except for one, and we'll get to that one quite soon. But, you know, this is the important thing. Like, it's in a way like Agile. Personally, these frameworks are there to help you, and if you find that they're not working for you, then you should be able to kind of adapt them to a certain extent. So MITRE attack, yes, it is an and, but you kind of say it like attack. Adversarial tactics, techniques, common knowledge. And this is in particular used, to basically think about how someone is going to actually attack your system. There's a similar one by Lockheed Martin called Cyber Kill Chain. And they're kind of a similar thing. This was first released by MITRE in 2018, and it's what I like about MITRE as opposed to Cyber Kill Chain is that MITRE is just a free and open source pool of knowledge. It doesn't, it just thinks about how something can be attacked in the most general of terms. It takes it from a perspective which is, it's like, so it uses tactics, techniques, and procedures, which is essentially, thinking of it from a terrorist point of view. And it's using intelligence of what has kind of happened before. So it's not kind of really thinking outside the box. It's actually saying this attack happened on this day, and because of that, the likelihood of this is going to improve. Is it good for open source? I don't know. But I think probably, potentially, maybe not. It's mainly best used when you're actually thinking in a red team attack capability. Obviously, because they are tied to adversaries, it is very tied to that red team thinking. So we also have Dread. So it's a mnemonic of different areas. Now, Dread, it's basically qualitative risk analysis. So it's based on opinion. So opinions change, right? You can't have a particular opinion. How do you say one opinion is better than the other? Well, the truth is that really you can't without some kind of factual underpinning. And what Microsoft found is that, the same things are being scored highly wildly different because scores are, subjective. So Andrew Shostak, there was he mentioned that Microsoft banned it in 2008. They don't use it in their stuff. Abandoned, sorry, not banned. It's still used by some businesses though, because I don't know whether it's a knowledge that they actually find some good use in it, or whether for them it just works better. So it's kind of worth bringing up. But it is kind of like the people that kind of created it at Microsoft, they have kind of not used it anymore. So then we go to pasta. Anyone hungry at the moment? Yeah, there's definitely a few. Right, excellent. I always get really hungry when I think of this, don't know why. But attack simulation and threat analysis, it's quite a similar thing to MITRE attack in that sense, but it has 7 stages. So you can imagine this is it takes quite a while to go through all of the stages sometimes. But it's centered around risk, your appetite risk. So you have stage 1, which is to define your objectives. Based on, so basically how do you define objectives? You go through regulatory influence, you go through a load of policy documents, you might even look at your company records. Data classifications that you might have, particularly if you work in government maybe. Stage 2 is defining your technical scope, what your attack vectors, boundaries, identifying dependencies. And then you have stage 3, which is breaking down the application, data flow diagrams, asset models, which then goes to stage 4, which is the analysis of threats, which I guess we've now taken stage 4s to get to the third question of, what is the threat? Then it goes to stage 5, which is then analyzing the vulnerabilities, and then stage 6, which is analyzing the attacks. Finally, by stage 7, you've got a risk and impact analysis. So it's quite long-winded, right? It can take some time. So Linden. So Linden in particular is a bit of a different one. It's quite a mouthful as an acronym mnemonic. Again, it's another one where each of these sections means something and is scored appropriately. So in particular, this is only used in privacy. So threat models don't have to actually be open source, as we said. So this one actually focuses still on open source though, but with a privacy perspective. We think of these things as applications, and the ability to about repudiation is a bad thing. Linden actually scores, it's better to have non-repudiation. So it's a huge conflict one, really. Sometimes privacy and security aren't the same. They are actually quite different. So it's an interesting one to maybe do if you have time, as well as one of the others, to choose maybe Lyndon to think about your privacy leakage as well, and the threats around that. So, yeah, that's kind of what I roughly have said. It comes in an easier to learn version called Lyndon Go, and that's kind of like unfamiliar to privacy, which I'll kind of touch on. It's kind of a card game, which is very similar to Stride. So Stride isn't a card game. There's a card game called Elevation of Privilege, which is basically devised by Adam Shostak quite some years ago. And it's, again, like Lyndon Go, Elevation of Privilege, they are ways of introducing threat modeling to those that might be unfamiliar to it. Stride in particular, spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. It's much more direct than the other frameworks. Basically it kind of says, these are the 5 things that could happen in your system, and what you're going to find is actually what it will fit somewhere. Developed by Microsoft again. This one's actually the oldest. It's been around for many, many years. 1999. 23 years now. Well, 24. It's still incredibly popular because it's straightforward to use, and it's kind of best served when you actually have a system that you know quite well, and you now want to answer questions on it. So if we kind of like go back to our 4 questions, those are 4 questions that are being asked, and we can keep repeating those with Stride, and we can keep moving on and saying, well, did we do a good enough job? And if we haven't, then we can go back and keep repeating, right? So, is that all threat modeling is? No, that's a framework. So what a framework does is it moves to a diagram. Now, this diagram is, as I say, working with Sal, Michael Crenshaw, and Zach Aller from Argo CD. I think they came to us a few months ago. And we've been helping them really, trying to define different areas of boundaries. What is threat modeling and what isn't? Threat modeling is a threat. If you see a threat in a system, then put it down, model it, try and understand that threat and how to mitigate against it. So as you can see within here, we have, on the right, on the left-hand side, we have, like the build infrastructure. Now, is that part of Argo CD? Not really. But actually, what we have seen in recent times with SolarWinds, etc., you can attack at the build area. You can, in a way, have people that will infiltrate a business, sit there for 7 months if they want. And this is not SolarWinds, this is me being highly general. But you can infiltrate a business for 7 months. You can sit there, learn, understand, all to do with the server infrastructure, and then one day maybe decide to be an insider threat. You can have somebody that is actually working completely innocently, and might also be a threat. The possibilities are endless, but how do you do that when you're considering an open source project? Now, I think with anything, you can think of an infinite scope, which is completely wrong, right? You need to time box this. You need to actually think that what is your responsibility in this? Are you responsible for the fact that someone ingested your open source library, so therefore you now have to think about different parts of the library, and you have to think about, whether that person employed someone? Not at all, because, it's out of your scope. So, we'll ask the question again, what is threat modeling? So, let's say what isn't threat modeling. I mean, the existence of a threat model doesn't actually imply something is secure. You could go through this, you could ask questions, you could, understand things, you can write things down, but if you don't actually change anything, it's just a model of your threats that are very much alive, right? That's not secure. Value, as we saw in the initiative, is contextual, and so are threat models. You can't, just because your opinion of what is important to you is fixed, does not mean that somebody else who might even use your product or your project is, they might have a different idea of what a threat model is. It's not just a diagram. It might look nice, but this is the basis of a threat model. what we now need to do is ask questions. So, for example, all these connections, are they HTTP? Well, that's really bad. Why are they not HTTPS? If they're TLS, what version of TLS? Are they 1.3, which is secure? If they're not, then we need to change that, or we need to raise tickets. In our infrastructure, how do we know that the people that are contributing to our open source project, how are they? Are they vetted? Do we have some kind of API keys that we could trace on them? Do we, lock down main branches? Do we, it's all these questions that kind of how do we connect in a Kubernetes structure, that's inherently open? Are we doing enough? And then, there's no need to boil the ocean. So if you're happy within your section that, your threat model is fine, then great. And what I think is important is probably to have threat models within open source to say, these are the things we haven't really thought about. We've thought about them, but we don't want to go further because actually that's somebody else's job. Or, whether that's the user or whether that's, a big corporation or whatever, But here's my limitations, and I think that would help, certainly, the community. So there's no need to boil the ocean on this. And collaboration is actually key. Shouldn't be, one thing that I've had before is threat modeling taught of, well, can I have your diagram? They'll say, we'll help you, but you need to create the diagram from scratch. And if you don't know what threat modeling is, how do you start on your diagram, right? How do you know all of the things that need to be mapped? So I think having sessions, at least at the beginning, to kind of say, let's work through this together. This is what we need as security people to say what we need to effectively assess the threat. We're going to ask questions, and they're going to be uncomfortable, but hopefully they're also going to be questions that you can give answers back to, and you're going to enjoy it as well. Most of all, this isn't war, so you get a lot of talking around cybersecurity about, in particular, Sun Tzu quotes, like the act of war. And, I think, especially if you had a military background, I don't, but I would find that quite upsetting, that it's kind of, we're actually, it's not war, it's about, finding, threats, but that's, it's to make our lives better, it should be a welcoming thing, So, collaboration is key. Threat modeling is best done with a group as diverse in thought as possible, right? I will not think the same as somebody else that has never lived my history. They will think different to me. The more people you can get involved, it's not just for developers, it's not just for security people, it's not, if you have anyone that wants to get involved in the open source project, I think bring them all in. They might have, one of the best things I've had is played stride games, for example, or used different parts and then found, wow, okay, I didn't even think of that. And then you can plan it. It's great. Security really is for everyone. So that's a rough thing of what threat modeling is. It is a bit whistle stop. So what does this actually mean to open source? Well, open source has got loads of threats, right? You got 742% year-on-year increases in software supply chain attacks since 2019, as we hear from the State of Software Supply Chain in its 8th edition by Sonatype. 6 out of every 7 vulnerabilities affecting open source are due to transitive dependency. So, thinking about kind of mapping these out and thinking, well, am I on the right version of this software? I know I'm using this. It's helping. And open source consumption is going to increase to 3.1 trillion total requests. So it's not going away. I think that's in the keynotes we heard earlier. It's definitely huge. It's something we need to kind of act on. And it's also difficult to model because you don't know how people, so much in software is it's difficult enough to know when you really understand a system and the infrastructure it sits on. It's difficult to understand how people will use that unexpectedly. That's why we do QA testing. It's why we do, penetration and mutation tests and all these other things that kind of help our lives get better. In the case of libraries, that your library might even be fine, but actually they might put it into an external bit of code, and then actually find that, oh wow, okay, it's actually we have a different inherent problem here. Once we're being interacted with in that way. You don't know the hardware that it sits on. You might think you might be threat modeling in your case for something that's bare metal, and actually realizing that they've put it into a Kubernetes cluster. It's a very different set of assumptions. So one thing that has kind of helped, say when working with Argo CD, is actually using something called Fragile, which was released a couple of years ago by Christian Schneider. It actually uses YAML to model architecture, and it will kind of generate these data flow diagrams that can be quite cumbersome to make quite simply. Once you've got the YAML set, it's actually very good. It has what's called a relative attacker attractiveness report. This is like a percentage, so when we go back to the diagrams, each of those has RAA with a percentage, and normally it's how the data flows between each diagram. It's incredibly useful from that. And not only that, it kind of also goes through, basically generates a PDF. It also generates a risk assessment, asset diagram, to help, and it also generates PDF to display risks and unmitigated risks as well. So Fragile is written in Go. It can be run in a REST server or a Docker container. And the best part of it, though, is you can create actually base templates. So this might be something that kind of open source can consider. If you're working in a Kubernetes cluster, they're going to have quite a similar structure. If they're working on base metal, there's a general setup for these things, right? That if your main configuration is server to server, that's going to have, you can make assumptions on that. And this might help security teams like the OpenSSF or CNCF, adopt these into their projects. So, as we said, data outputs as a PNG. And output risks and identified as PDFs. Now, how do we do this for open source projects? Well, probably putting it into a .security folder. Think of like GitHub, for example. GitHub is a .github folder, which has various license information. It has all sorts of things that now allow people to ingest that in the project. I think Maven Central has the safety rating, again, Sonatype safety rating, which is based on how a project is considered, it's a metric on how safe we consider that project. Now, if we could add a threat model to a .security folder, now we can actually maybe put that on a front page somewhere and say, this project has gone through a model analysis, and now what we can do is say, it might not be right, it might be ongoing, but at least that process is happening. And then that might help other people think, do they want to have that as part of their project or not? So, very quickly, are we doing a good enough job? So, I think with all of these things, we go back to that question 4. Are we, as open source professionals, as people that work in tech in general, are we doing a good enough job when it comes to understanding threats or understanding security? There's quite a lot of different organisations now. The NCSC over here is very good at, they've been great with getting a lot of really good information out. NIST over in the States and generally worldwide. BCS here again, great. In particular, they've just kind of ramped up the cybersecurity special interest groups that I think is very important. And then obviously the OpenSSF and CNCF have been doing some really good work. In particular, they have the OpenSSF scorecard. So some work that was done by Sonatype, but they basically looked at what is the most useful thing for identifying vulnerable projects, right? So we have code review, followed by dependency pinning, followed by binaries, followed by locking down major branches. So what can we say about that? Well, threat modeling really if you think about it, code review is the best thing we can do. Threat modeling is actually a security code review. And if you think about it as something that you do at design and throughout, little bit by little bit, it can be as important as a code review. It's that's the most effective way of reducing errors to a code base. And having defined threat model templates backed by open source organizations will be really important to speed up this adoption. So now we've got the model, what else can we do? Well, we can use tools to manage threats, and there's loads of free ones that open source can use. There's great rapid templates of known infrastructures, and really question your open source projects. Even if you're not the project owner, there's nothing to say to you. Well, let's see what I can find out about this project, and is that going to help me for what I want to use it for? Because security is for everyone. Thanks for listening. Oop.
I actually have a question for you. How is threat modeling for an open source project different from doing it on your own surface area in a corporation? What are the factors that you might have to consider?
I think a lot of the difference is that a lot of open source projects just don't have the amount of people that you have in corporations. So, you have to think about ways of trying to get different people to collaborate on them. There's also that you don't really, in a corporation, what your infrastructure is, right? You understand because it's what your company's paid for. With open source, you can have different libraries can work on various different things, which makes it much more difficult. But I think it actually makes it also opens up another set of questions which might be helpful.
Any other questions along the way? Oh, excellent.
Run. Thank you. Merci. So we know part of the problem of open source is the complication that it's mostly voluntary workloads or underpaid, understaffed projects. But where does the buck stop with open source? And then if the security is spotted by a corporation, then should they be morally required to fix that? Or who's in charge of the security of open source? Small question.
Who is in charge of the security of open source? I mean, that is a really good question, right? And I think there is a certain bit of self-accountability. I'm not saying it's anyone's fault. I think in a way that's the wrong way to think about security, right? We should want to be secure. We should want to make this better, And I think, I think having the option of, it's somebody's fault. I think that's the kind of wrong, or that's somebody's responsibility. I think that's the wrong way of framing it. It should be everybody's responsibility who wants to impact open source. We should all be thinking, even if we're not coding it, even if we're not involved in the security conversations, we should be thinking, how can we make this better?
Great talk.
Thank you.
Often the outcome of a threat model can be quite abstruse and difficult to comprehend. Do you have any favourite ways of presenting that final piece of information to, and perhaps there are different audiences as well as different roles that they have, so for any of those permutations?
Yeah, I think, to be honest with you, it's really weird, like general reports, PDFs explaining in words and tables actually is the best way sometimes of getting across a lot of information, but also non-technical. You kind of try and say it in the most simplest ways to kind of explain, well, how does that impact the project? How does this impact what I'm trying to do? I think that's, a lot, so for example, we go back to the architecture diagrams. That's great if you're a developer. It's great if you work in security because you're used to seeing them. But some people might not be, some people might, and that kind of keeping it as a architecture diagram and nothing more kind of just blocks out whole areas of open source that want to get involved, but they might not necessarily be able to read that particular way of conveying something. So I think the more different ways that you can explain things and pointing to not saying don't do a diagram, but do a diagram, then have a proper write-up, do a report, point to these things, point to these tables, make it very clear this is wrong because here's the CWE or the CVE that says it's wrong, right? And let people kind of make the connections, and then they can help as well.
One more question. So when I think of threat modeling, I kind of think of it, and I explain it to people this way, right? Like, consider it a body, like a human body that has an immune system that will flare up. And when we're doing a threat model, it just means we went to a doctor on one day and they said, here's what's up, here's kind of the elements that you may need to pay more or less attention to. And I think that's really interesting, but increasingly, the adoption of threat models in open source, I think, gives us an incredible opportunity that I'm excited about, of not having every maintainer relearn the basics of security. So as we're reaching out to packages and we are teaching project security, can these threat models genuinely, and this is still really an open question, but do we have the potential here to template those threat models and communicate in plain language to the audiences that do not understand these, bake into those some of the fundamental security limitations of those ecosystems and languages. So it's both a learning opportunity for those developers as well as an opportunity to expand that with their own package knowledge.
Yeah, I mean, I think that is a great idea. That is great to template these things to explain, because that's what is needed. I think the more people we can get involved in this, the better. It's about, as I say, there's so many projects which, I think actually, a lot of open source, there's a lot of investment into it. But sometimes, it's more about kind of producing the thing for that particular area. I think, in a way, what we need is, one, get a basic standard of kind of tooling, so these products can ingest things and tell them these are the threats, because you might be unaware of them. But also then on top of that, then have these kind of community-based, let's show what your information is. Let's get that. We have a base template for what you do. You can use this, and then we can build on that by having discussions, but deeper into your code base or into your architecture to kind of explain, well, okay, now you want to be you graduate to CNCF projects, here is how you can make that happen.
And keep going to the doctor. You can't do it one time. No,
exactly. Yeah, definitely. I mean, this is the thing about threat modeling as well. It's not something you do at the beginning of the design phase and that's it. It's not something you do at the end of the project. It's a very agile process. It's like, gardening. It's something that has to keep happening time and time again. And it's not like, what it shouldn't be is something that somebody kind of comes in and goes, oh, this is wrong, do it. It should be something that, as a collective, everybody involved in the project should want to be able to do.
Excellent. Are we good on questions? All right, well, thank you so much.
Thank you, everyone.